Okay, so I've got an exam question here, and this sort of involves conditional probability. And if we remember, we know that conditional probability means or refers to um, finding out the probability of an event given that we already have a condition or given that something's already occurred. So if you read this question, we've got the probability of a light bulb being defective is 5%. This probability reduces to 3% when the manager is working. So we can see already that this is our sort of condition, right? When we look for words like when, if, those sorts of words that tell us that there's some sort of condition that's happened or some sort of condition that we have to consider when we're finding our probability. So this probability reduces to 3% when the manager is working and the manager is on duty 65% of the time. Now, using this information, we have to find the probability of a defect given or if the manager is on duty. So again, that's our condition here. So our condition is, we have to find the probability of a defect given the fact that the manager is on duty. Okay, so what we're going to do first is we're just going to list out some of the information that's been given to us in the question itself. So we know that the probability of a light bulb being defective is 5%, which is what we've got here. Now this probability reduces to 3% when the manager is working. So how do we what's the notation for that? We write that the probability of a light bulb being defective, given that the manager is working, that goes around to 3%. And if you think about it logically, that kind of makes sense, right? If you got the manager there, people are probably going to be more careful, they're going to be working, a bit more carefully, a bit more harder. So the likelihood of a mistake is going to be a bit less. So that's a probability of a light bulb being defective, given that we have a manager on duty, and the manager's on duty 65% of the times. The probability of there being a manager is also 65%. Okay, so that's our three pieces of information, or our three numbers that you're given. And I will see this written down, the conditional probability formula here, which states the probability of A given B is equal to the probability of A and B happening divided by the probability of B. Okay? Now, to make this question easier for ourselves, what would be good to do is to draw a tree diagram, right? We've got a multi-event sort of thing. We've got a condition happening. So wherever possible, if it's not too difficult, if there's not too many events, we can try drawing tree diagrams for our questions. So the first sort of leg would be regarding if the manager's on duty or not. Okay, that's what we're going to have first, because then depending on if the manager is there or not, the probability of a defect or not having a defect, that will change accordingly. Okay, so we know that the probability of there being a manager is 65%, so that the probability is 0.65 here. And conversely, the probability of there not being a manager is going to be 0.35. Now, if we look at the second leg of the tree diagram, if we know that if we do have a manager, if the manager is on duty, the probability of there being a defect is 3%. Okay? And therefore, the probability of there not being a defect is going to be 97%, or 0.97. Now, when the manager is not there, we know that the probability of light bulb being defective is just 5%. So we've got 5% there, and therefore the probability of not having a defect is going to be 95%. Now, the question is asking if the manager is on duty, what is the probability of a defect? So it's asking the probability of a defect given that we have a manager. Now, technically, we already know this information here. They've already given that to us. Well, I'm just going to show you how to calculate it anyway. Just sort of build that practice. And since it is an exam question, there would be 2 or 3 marks related to this question, so we would need to show this working as well. Okay? So, again, using this formula up here, the probability of A and B, so the probability of there being a defect and being a manager is going to be 0.65 times 0.03 divided by the probability of the manager being there, which is 0.65. Put that along and you get 0.03, which we know is correct because it's the same number as they've given us. But we're still sort of just calculating that just to make sure that we're getting all the working out marks. Now, the second part of the question asks us it's sort of the other way around. It's saying, if you find a defect, what is the probability that the manager was on duty? Okay, so again, put the same information here, Okay, we've got the tree diagram here as well. You can see we'll just switch it around. So now we've got the probability of a manager given. So what is the probability that the manager was there given that there is a defect? Okay. So again, the top part is going to be the same. It's the probability of the manager being there and having a defect, which is 0.65 times 0.03. And the bottom is the probability of there being a defect. Okay. Now there's two ways we can have a defect, right? We can have a defect while the manager is there, which is 0.65 times 0.03, or we can have a defect while the manager is not there, which is 0.35 times 0.05. And that's what we put on the bottom here to get our final answer of 0.527. This important thing to remember is just to make sure short laws are working, using the formula and using diagrams where applicable to really make it easier for you to solve the question.